Good day, I'm Maile Matsiba. Welcome back to our channel. We continue with our 2017 study guide of our CIR 113 module. We're looking at the second last of the examples, which is example 5.4.3. It says the table shows the solubility data of sodium carbonate in water. And there's a table, and it goes further to also say that interpolate linearly if required. Now the question is, what mass of Na2co3 10H2O must be dissolved in 100 kilograms of water to give a saturated solution at 67 degrees Celsius? So they actually need to know how much of Na2co3 10H2O needs to be dissolved in 100 kilograms of water to actually give a saturated solution of 67 degrees Celsius. So now when you look at the solubility data that we've been given the solubility data with your 20, 40, 60, 80, and 100 degrees Celsius. We don't have the exact 67 degrees Celsius, which means we're going to need to interpolate between 60 and 80 just to make sure that we get the solubility data, and we'll do just that. So now the first thing we need to do is just let's choose a basis. Basis. And as usual, it will be easier to use the basis when it's use this basis. So it's 100 kilograms of H2O. So this is actually the stream. So yeah, and then now remember that we want the solubility data at 67 degrees Celsius. So let me just say, let X be the solubility of Na2co3 in water at 67 degrees Celsius. So that is actually our unknown. Our X is actually the solubility of Na2co3 at 67 degrees Celsius. And if you're going to calculate that, then it takes us to step 1. Let me just write here that interpolate linearly to get the solubility of Na2co3 in water at 67 degrees Celsius. So that is actually our first step. We're going to actually interpolate, and as soon as we get the solubility data of Na2co3 in water at 67 degrees Celsius, then it's going to be easier to actually follow from there and answer the question, which is what is the mass, and so now that is actually the first thing we're going to be doing. And as far as we know interpolation, you can always say 80 minus 60 all over 45.8 minus 46.4 is equals to, and then we'll interpolate. Let's realize that 67 degrees is actually here, somewhere here, right? And our X is actually somewhere here. So interpolating, we can easily say 80 degrees Celsius minus 60 degrees Celsius all over 45.8 minus 46.4. It's important to understand that the units of these numbers underneath here is actually grams Na2co3 per 100 grams of water. Just that it's a little bit difficult to plug in there, but at least have that in mind. So 80 minus 60 over 45.8 minus 46.4 is equals to, now we come here, we say 67 minus 60, 67 degrees Celsius minus 60 degrees Celsius all over 67 goes with X. It's all over X minus 46.4, which is what goes with the 60 degrees. So that is actually our equation. And if we move further to actually do the simplification of the equation, you can easily simplify and do our high school arithmetic and make some rearrangement, and that will give us, let me me just write it down. 67 degrees Celsius minus 60 degrees Celsius. And then we have 45.8 minus 46.4 all over 80 degrees Celsius minus 60 degrees Celsius, everything plus 46.4, 46.4, right? So that is actually simple. It's not even high school mathematics, it's actually high school, it's not even varsity mathematics, it's actually high school arithmetic. So we have our x's that, and if you move further to do your simplification, you will get your 7 degrees Celsius all over 20 degrees Celsius multiplied by minus 0.6 plus 46.4. And if you simplify, finally you will find a solubility of 46.19 grams Na2co3 per 100 grams H2O. So this is actually now the solubility. This is actually the solubility of Na2co3 at 67 degrees Celsius. So with that said, we are actually done with our first step. So now, as soon as now that we're done with our first step, it takes us to actually our second step. And let me just bring back the paper here. Let me just write step 2. Remember the question that we have been given. They say, what must the mass of this be? How much of this must be added in 100 kilograms of water to give a saturated solution of Na2co3 in water at 67 degrees? So the second step is we're going to need to calculate the mass fractions of like your Na2co3 in water at 67 degrees. So we know this is actually a saturated solution at 67 degrees, but we don't know how much of which is in here. So we're actually going to try to calculate the mass fractions of that so that we can figure out that. So that is actually going to be our step 2. Let me just write it down, that calculate the mass fractions of Na2co3 and H2O at 67 degrees Celsius saturated. So now our step 2 is we want to know how much of Na2co3 and H2O are in there, and yeah, that's actually how we're going to move. Now, therefore, mass fraction Na2co3 is equals to the mass of Na2co3 all over the mass of Na2co3 plus the mass of H2O, right? And we already know that at 67 degrees there's 46.19 grams of Na2co3 for every 100 gram of H2O. So this is actually what we're going to be using. It's easy to use that to actually get the mass fraction. So we can use the 46.19 grams all over 46.19 grams plus 100 grams. And then if you use a calculator there, it's gonna give you 0.3160. This is actually the mass fraction of Na2co3. Now we move further to do the mass fraction of H2O. Remember that it's actually very possible to actually get the mass fraction of H2O by saying 1 minus this, right? But for explanation purposes, I'll just keep the longer root. So it's 100, which is actually the mass. This time it's H2O, the mass of H2O all over the total mass, or the mass of both, plus 46.19 grams. And if you use a calculator, it gives you 0.6840. So now we have the mass fractions of both Na2co3, and this is actually our step 2. Now we're moving forward further to our step 3. Let me just write it here and say step 3. Now in our step 3, we're going to calculate the mass fractions of Na2co3 and H2O in the stream here. So that is actually what we're going to be doing. So calculate the mass fraction of Na2co3 and H2O in Na2co3 10 H2O. This is actually what we're going to be doing in our step 3. We're going to be calculating the mass fraction of that, and we can start by the mass fraction of Na2co3. Therefore, mass fraction Na2co3 equals to, let me just explain something here. Remember, initially when we were calculating the mass fraction of this stream here, it was a little bit easier because we had the masses here. But now in this regard, for us to get the mass fractions, we're actually going to use the molar masses. So it's going to be easier that way. And the molar mass of, let me just write that mole mass Na2co3 all over mole mass Na2co3 plus mole mass H2O. So yeah, and therefore mass fraction Na2co3 is equals to the mole mass of Na2co3. You will find it to be 106, either grams per gram mole, pound per pound mole, kilogram per kilomole, whatever it might be. So I'll just keep it as 106 without units, all over 106 plus the mole mass of H2O is actually 18, but you know there's a 10 here. Where's the diagram? And remember, there's actually a 10 here. If you look at it, it's 10 H2O. It's 18 by 10, so that makes it 180. So it's all over 180. And that becomes the mass fraction of Na2co3. And if one uses a calculator there, they would get 0.3706. That becomes then the mass fraction of Na2co3 in here. Now it takes us to the mass, we're calculating the mass fraction of H2O. Mass fraction of H2 equals to, it's the same thing, this time it's 180. So we have 180 all over 180 plus 106. And if you use a calculator there, it will give you 0.6294, right? That then becomes the mass fraction of H2O in this stream here. Is the mass fraction of H2O in here, right? So now that concludes our step 3. It then takes us to our step 4. let me just write it down that step 4. Remember, let's go back to the question. The question says how much of this must be added in this to give us a saturated solution. So now in step 4, we are actually answering the question directly now. Now we are actually calculating the mass of this that must be added in this to give us that. And with that said, when we get here, I would like us to actually define this stream as y for calculation purposes, because we're going to be establishing equations, and then let's name this as y and this is z. We can't use x because we already used it in the solubility, so it should work perfectly well. There's no problem. So yeah, so with that said, now that takes us to our step 4. Let me just write down the step 4 there. Calculate the mass the mass of Na2co3 10H2O that must be added to 100 kilogram of H2O to give a saturated solution at 67 degrees Celsius. This now is actually our step 4, and with that said, we're going to now be establishing equations. Like I said, that let y be that. Let me just write it down. Therefore, let y be the mass of Na2co3.10H2O and let me just say dissolved in water, and Z be the final saturated solution at 67 degrees Celsius. I hope it's clearer. Yeah. So this is basically what I've written down, that let y be this stream and let z be that one. And with that said, we're actually going to be doing establishing equations, and now we're going to be doing an H2O balance. We're going to balance all the water. We know there's water here and there. So the water here plus the water there is equals to the water there. So we know that this is 100 kilograms. So we can just say, therefore, 100 plus this one here. We don't know why, but we know the mass fraction. We know the mass fraction of water in here. We did calculate it. So we know it is we found it to be 0.62. Let me just bring it back just to verify. Yeah, this is it. This is actually where we calculated it. So yeah, we calculated it here, and then it gave us 0.6294. Therefore, we're going to say plus 0.6294y. This actually then becomes the mass of water here. It's equals to, we know the mass fraction of water in Z, we calculated to be 0.6840. That means the water here is going to be 0.6840Z. And that is actually then our first equation. So we have just made the water balance, and we found that equation, and yeah, Now the second thing we're going to be doing, now that we are done with the water balance, we have two unknowns and one equation, and as usual, then we're going to need our second equation, and this time around we're going to be doing an Na2co3 balance. So we say Na2co3 balance, Na2co3 balance. Now when you look at here, we know there's no Na2co3 here, but there is Na2co3 here and also Na2co3 here. So we know we're going to use the mass fraction of Na2co3 here to calculate how much of Y is in it, how much of Na2co3 is in Y, and also do the same with the mass fraction in the Z. And if you do that, we know that the mass fraction of Na2co3 in Y is actually 0.370. We calculated it. So we're going to just say 0.3706Y. That becomes the mass of Na2co3 in here is equals to, there's no Na2co3 here, so it means all the Na2co3 is in here. Now when you come here, the mass fraction is 0.3160 Z. Yeah, therefore with a little bit more of simplification, you can just say 0.3160 Z all over 0.3706, and therefore our Y equals to 0.8527 Z. And with that said, this then becomes our second equation. So we have two unknowns and we have two equations. So we'll do the normal, what we always do, which is the solving of the simultaneous equations to solve for both Y and Z. And we'll do just that. And with that said, when we move forward, we can just say we need to substitute 2 in 1. Where's our 1 in 1? Let me just write it down, that substitute 2 in 1. We're going to be substituting 2 in 1, and with that said, we're going to get 100 plus 0.6294 0.8527 Z. Remember here there was Y, and we know that our Y is 0.8527, like we calculated it. We just did now. So this is actually our Y. Where there is Y, we plug in this value, and then with that side, as we continue, we get is equals to, this side we have a Z, so we don't really have a Y, so we'll keep it as a Z, 0.6840 Z. So that becomes actually our equation. Is one equation with one unknown. So moving further, as we simplify it, we can actually be left with 100 is equals to 0.6840 Z minus 0.5367 Z, right? And if you do the calculation, you'll find that the Z becomes 678.89 kilograms. Now with that said, our Z, which means the total mass, the side, is actually 678.89 kilograms. So we have managed to solve our Z, and moving further, we can then now go to our Y. We can just say from 2, which is our second equation from here. Now that we have the Z, we can just say from here, we will actually be able to calculate our Y. So we say Y is equals to 0.8527 And then where there's the Z, we substitute the value of 678.89 kilogram. And now that gives us 578.89 kilograms. And now we have answered the question. Remember, the question says, what mass of Na2co3 10H2O must be added to 100 kilograms of water to give us a saturated solution at 67 degrees? So how much of this must be added to this to give us 67 degrees saturated? So our which is our Y is actually 578.89 kilograms. So we have answered the question. We know we need to add 578.89 kilograms of Na2co3 10H2O into 100 kilograms of water for us to be able to find the final solution of 67 degrees Celsius that is saturated. So thank you for your time, and I hope we meet again in a very last example, which thank you.